Welcome to my deep dive into NiceGUI, a powerful Python framework for building interactive web applications. In this video, we will explore 4 NiceGUI topics that I did not cover in my introduction to NiceGUI. These are data binding, creating and updating lists, data storage options, and how to create custom Vue.js components that you can use in your NiceGUI projects. I will be jumping right into code examples to illustrate these topics. I recommend that you view my Introduction to NiceGUI video if you are new to NiceGUI. There will be a link to that video in the comments below. The code examples are in a demo application that I have created for this video. You will find a link to the GitLab repository that contains the code for this application in the comments below. But first, let's quickly review what NiceGUI is and why you might want to use it. NiceGUI is a Python framework for building interactive desktop applications. It uses an embedded web server to render your user interface. The UI components are built on top of the Vue.js JavaScript framework, plus other popular web tools for styling and layout. It comes with a large set of built-in UI components and can be extended to incorporate your own custom Vue.js components. Our first topic is data binding. If you are familiar with data binding in web applications using Vue.js or React, data binding in NiceGUI will look a lot like what you are used to. For those of you who are new to data binding, it is a technique in modern web frameworks that synchronizes the data in your application with the user interface. This feature allows us to simply declare that a particular piece of data is bound to a particular user interface element, and the framework takes care of keeping the user interface in sync with the data. It can also allow us to control element visibility and other properties based on data values. Data binding can be one way, where changes to data values automatically update the user interface, or vice versa. Data binding can also be two-way, where changes to either side are automatically reflected in the other side. NiceGUI contains a set of methods that allow us to bind to values of properties of our user interface elements. A function naming convention is used to indicate the direction of data binding, to or from. Bind to methods update application data when a user interface element changes. Bind from methods update user interface elements when application data changes. Bind methods without to or from in the name perform two-way data binding. You can bind various attributes of user interface elements. The attributes value, text, content, and source affect the content of an element. Which method to use depends on the type of element you are binding to. Specifying visibility or enabled will affect the behavior of an element. The application data that we reference can be a simple variable, a value within a dictionary, or a value in one of the global data stores that NiceGUI provides, such as user storage or general storage. Here are all the data binding methods in NiceGUI. I will demonstrate how to use these methods next, and we'll cover global data storage options in detail in a later topic. We're now looking at a simple NiceGUI application that demonstrates the concepts covered in this video. On the Data Binding tab, there are 6 examples of data binding in action. In each, you can see a code snippet and interact with the corresponding user interface element. The first 2 examples demonstrate one- and two-way binding to variables in an application. The first binds one way between an instance variable of a class, called myBinding, and a label element on the page. If I were to change the variable value in my code, the label element would be updated accordingly. The second example is similar, but binds to a value in a dictionary instead of a simple variable. It also binds the variable two-way to an input element. As I type into the input element, the text value in the dictionary is updated, which then causes the label element to be updated. Changing the variable programmatically would also update the input and label elements. The third example is almost identical to the first two, but it binds the contents of the input element directly to the label element without using an intermediate variable. The fourth example binds the input element to a variable in user data storage. This value will persist between multiple runs of the application. Our next topic will cover data storage options in more detail. The fifth example demonstrates how to bind to a select element. Whenever the user selects an item from the drop-down list or clears the selection, the bound variable is updated with the selected value and is shown in the label element. The last example shows how element visibility can be controlled with one-way binding. Our next topic is how to manage lists of data in NiceGUI. I am focusing on this common bit of functionality because it may not be obvious how best to create and manage scrollable lists of data items in NiceGUI. Here is a page that lists the NFL games for the 2024 NFL season, 1 week at a time. The plus and minus buttons move forward and backward through the weeks of the season. The game data is stored in a Python variable as a list of dictionaries, each of which contains the data for one game. If you were working with Vue.js, you would probably use an iterator within a tag, for example, a div containing a v-for directive bound to some sort of JavaScript array. Your user interface would automatically re-render the list when your data changes, for example, when a new week is selected. NiceGUI does not have a corresponding method of telling an element to iterate over bound data, so a bit of code will be required to handle this. In the sample code shown here, I first create a couple icon buttons to allow the user to move back and forth through the weeks of the season. I then create a UI list element to hold the list of games, saving the element as _football_list. Then, inside the with block, I call render games. That method clears the contents of the football list element and then repopulates it with the game data for the selected week. This method is called once at startup to populate the list with the first week's data, and again whenever a new week is selected. Now let's talk about global data storage. There are 5 options for storing your data values. Each has advantages and disadvantages. They differ primarily in the scope of the data and how long it persists. You can, of course, store data in simple variables and objects within your application, but the scope of these will be determined by their lexical scope. They are not shared between users and do not persist between runs of the application. The 5 global data storage options are User, Client, Browser, General, and Tab. My descriptions are from the NiceGUI documentation, but I will note some observations from my testing that seem to differ from the online docs. I will demonstrate the 5 storage options using the demo application. I have split my browser into 2 windows, each showing the same page of the demo application. One browser with 2 side-by-side views of the same page. There is a separate section for each storage type, showing the code that is being rendered for each storage type. Each section has an input element that is bound to a value in one of the 5 storage locations. User storage stores data server-side in a dictionary associated with a unique identifier held in a browser session cookie. Values are unique to each user and are accessible across all their browser tabs. An ID field is used to identify the user. A storage secret is passed to the UI.run function for signing the browser session cookie that holds these variables. Notice that as I type into the input element on the left, values in the right-hand page are updated too. Client storage data is stored server-side in memory, and this dictionary is unique to each client connection. It can hold arbitrary objects. Data will be discarded when the page is reloaded or the user navigates to another page. Unlike data stored in tab storage, which can be persisted on the server even for days, client storage helps caching resource-hungry objects such as a streaming or database connection you need to keep alive for dynamic site updates, but would like to discard as soon as the user leaves the page or closes the browser. You can see in the client storage section that the value in each page is independent of the other. Unlike the previous types, the browser storage dictionary is stored directly as the browser session cookie, shared among all browser tabs for the same user. However, user storage is generally preferred due to its advantages in reducing data payload, enhancing security, and offering larger storage capacity. By default, NiceGUI holds a unique identifier for the browser session in the ID field of the browser storage dictionary. This storage option requires the storage secret parameter to be passed in the UI.run function in order to sign the browser session cookie. As you can see, however, data entered on one page is not reflected on the other. Data in general storage is also stored server-side. This dictionary provides a shared storage space accessible to all users. As I type into the input area on the left, the value on the right is updated. If I were to view this page in a different browser, I would see the same value there as well, and if I made changes, all 3 pages would be updated. Tab storage is stored server-side in memory and is unique to each non-duplicated tab session. It can hold arbitrary objects. Data will be lost when restarting the server, but this may change in future releases. Tab storage requires an established connection to the web server, confirmed by awaiting the client.connected function. You can see that changes in one page are not reflected in the other page, as implied in the documentation. If I reload both pages, you will see that client and browser storage are cleared. User, general, and tab storage values are retained. Here is a table from the NiceGUI documentation that summarizes the characteristics of the 5 global data storage options. This is a table summarizing my experiences with the 5 global data storage options in NiceGUI. Cells highlighted with yellow indicate discrepancies from the online documentation that I have encountered in my testing. Now let's take a look at how you can create custom user interface components that you can use and reuse in your projects. If you want to encapsulate a bit of user interface functionality into a reusable component, NiceGUI gives you 2 options. Both options create user interface elements derived from UI.element that can be used in your NiceGUI applications, just like any built-in element. The first option involves creating a JavaScript file that defines a Vue.js component, plus a Python file defining a class that derives from UI.element. This option is useful if you have Vue.js components from another web project or component library, or if you want the most efficient implementation of your component. It requires familiarity with Vue.js and JavaScript. The second option is to create a Python class that derives from UI.element and uses only NiceGUI elements, for example, from some existing code that you want to reuse in your app or across NiceGUI projects. I will show examples of both approaches. We are now looking at the custom component page of our demo application. On the left is a custom Vue.js component to look up word definitions. It is completely self-contained. On the right side is the NFL game browser that we saw on the Managing Lists page. Here is the JavaScript code for the dictionary component. It exports a Vue.js component definition using the Vue.js Options API. At the top is a template for the HTML markup. Then comes some JavaScript code that defines the component's data and methods. This is all just standard Vue.js stuff. Notice that we define a property, title, that is rendered in the template. In the HTML template, we see an input tag and a button tag. When the Enter key is pressed in the input or the user clicks the button, we call the getDefinition method. This method uses fetch to call the dictionary API. Results are displayed in a table using a v-for iteration directive. We are now looking at the Python code for the NiceGUI element that interfaces with the JavaScript code. The JavaScript implementation file is referenced in the class declaration using the component keyword. The class definition is very simple and just defines a property, title, in its props dictionary. The value for this property is passed to the Vue.js component's constructor. The NiceGUI framework takes care of linking the JavaScript code to the class and passing any property values to the JavaScript component. Here is the code for the Custom Component tab of the demo application. We can see that it just creates an instance of the dictionary component, passing in the title we want to display. NiceGUI takes care of the details of creating the component and passing in the title property value. All user interaction and data display is handled within the component itself. Going back to the demo application, we can open the Custom Components tab to see the dictionary component in action. If I type in a word and press Enter, the definitions are fetched from the dictionary API and are displayed in the table below. Creating custom components in pure Python is the easiest option. There is just one file to create and no JavaScript code to write. Implementing data binding is straightforward, and rendering the component is handled just like any other NiceGUI element. Here is the code that implements the NFL game browser. The Games class declares a bindable property named Games that will contain data for 1 week of games. It responds to data change events by calling its setGames method. The natural way to bind data to the component would be to call bindValueFrom, but because the UI element base class does not implement that method, I have created my own implementation. The code in the render method has been copied from the code in the Lists tab that we saw earlier. If we jump back to the custom component code, we can see the one-liner that creates an instance of the Games element, binds its data, and renders it on the screen. Above that is the code that renders the week number and buttons for moving from week to week. This code was copied directly from the Lists tab that we saw earlier. Back in the demo application, we can see that the NFL game browser is working exactly as it does in the Lists tab. Only a few additional lines of code were required to move this functionality into a reusable custom component. This concludes our exploration of advanced NiceGUI topics. I have described and demonstrated 4 advanced NiceGUI topics: data binding, managing lists of data, global data storage options, and creating custom components. These features of the framework add to the power and flexibility of NiceGUI. The result is attractive, intuitive user interfaces that can be created with minimal effort and code. All the code for the demonstration application is available in the GitLab repository linked in the comments below. Before I end this video, I want to talk in general about NiceGUI and my experiences with it. Bottom line, it's a great tool for turning your Python projects into interactive applications with minimal effort and coding. Its good attributes include its design and organization, the quality of the resulting user interface, its awesome online documentation, and the fact that it is a Python tool that brings along all the power and rapid development capabilities of Python. I couldn't really come up with any bad points about NiceGUI, but there are some features that I would put in the ugly category. First, in order to work with an underlying web server, NiceGUI spins up multiple instances of your application process. This complicates the usual test for _name that you might normally have in your application. And if you are doing initialization in your startup code, unexpected and undesirable behavior can result. Second, the application icon will be the same for all of your NiceGUI apps, and I have not found a way to change it. Plus, it's ugly. And finally, NiceGUI is a Python library for user interfaces in Python applications. That means the application runtime will be large, and you may encounter unexpected behavior due to weak or missing type checking, inadvertent indentation problems or misspellings, and unexpected variable scoping behavior. But if you are watching this video, then you, like me, probably appreciate the value of Python and understand what it is really good at and what it isn't. Thanks for watching this video. I welcome any comments or questions that you may have, and likes and subscribes are always appreciated.